All right, friends. Hello, everyone. Today will be a very simple video, but it'll actually take all day. So today we're testing a controller, specifically the Gray controller, all day long. So we're starting up with the new Gray controller, doing 3D engravings, doing 2D engravings, testing the cut here, testing everything. Meanwhile, we're turning on the stabilizer and the computer. Now we're gonna swap out this controller on the machine. It's a 2-click process. Let's just say the parameters will also be loaded. Actually, we won't even need to load them. So, today we'll cut some titanium materials, engrave some titanium materials as well, and prepare the files for engraving and cutting titanium respectively. And we'll likely make a couple more models for 3D engraving, specifically to test this controller. Let's put it this way. For most of you, this might be news. For others, it won't be. We have this test machine here that I use for tests and experiments. It's the JPT50LP. It's already, I think, 2 years old, if I'm not mistaken. So, actually, the most interesting part, this test machine has been working very well and efficiently for 2 years, and will keep working for a long time. Maybe because my hands are a bit closer to my head than my rear end. Well, maybe that's why. I'm not gonna show off or brag now, just stating the facts as they are. Replacing the controller is for those who bought equipment from us. There are short videos on how to change controllers, how to swap it correctly, quickly, and efficiently. So basically, everyone who purchased the equipment received a small set of training materials. A sort of easy launch or a quick start. And with this quick start, you can, well, understand how to change things, where to put what, how to transfer parameters and settings. Since we're using the exact same controller, we'll make it easier now. We'll just place the new controller on top. The new Gray controller, I'm saying this now so there's no misunderstanding. We're just plugging everything in here, no screw-in or bolting down. The lid won't close, obviously, so keep that in mind. So just simple, nothing fancy. The lid, we're just covering it with the lid here. This will be more than enough for the start, for the test. And let's get started. The next steps are as simple as possible. We'll transfer the files we need. In my case, it'll be these pics. We start the machine itself, launch ASCAD 2.0, and again, just so there's no misunderstanding, the first time you run ASCAD, it's done as an administrator. And one more thing, I'm doing this in advance now. Thinking ahead about hands, this is for those whose hands grow a bit lower or further from their heads. This isn't for the people this video is for, but for those other folks who always have something, damn it, breaking every 3 hours. We just have people like that who take the equipment and then say the equipment is crap, which is more than strange. Because in 6 years out of all my machines, I'm the only one who personally messed up a UV machine. Back then, I only realized this in the 3rd year. So guitar pick, let's do show preview, show to put center, the size of the picks. Press Ctrl U so we don't have to struggle with our fingerprints. We select them accordingly and press Ctrl G. Here we do the same, Ctrl G, and here we do the same, Ctrl G. The sizes of the picks are indicated. That is, we have 3 different types, 3 different shapes, and 3 different sizes. We will accordingly copy and paste everything we have here into one that fits us. Again, visually, more or less, let's make it 20 millimeters. So I think this will be more or less correct. Again, for the nuances, via shift, modification, aligning center vertically, and, well, it looks pretty good. It turns out, interesting, we can basically insert this option into some long pick. Right here, same thing. The height will be the same 20 millimeters. Via shift. Select, modification, aligning vertically, done. Well, we still have this pick. Oh, damn. Pick, finger, fingerprint. So we'll place it on this left option or this option. Same thing. Control C, Control V, size 20, done. And we add. So 20 doesn't work here. It also looks more than strange here. To be honest, let's look first and then decide for ourselves. Although basically it's also an interesting option. Modification, aligning center vertically, well, basically it also seems to turn out interesting. I'll just most likely there's no point in that at all. Here we'll probably make it bigger, 23. Yes, it will look better that way. But here, there's no point. In general, these 3 picks are what we'll be cutting today. The task is as simple as possible, so our task is, again, so we don't have repeated reworks later. We'll do one very important thing now. File, save as, pick 3 types finger. That is, only we'll remove the .dxf format here and save in EZD format. Done. My next steps. So I won't be using these picks, these shapes and structures. I'll move them to the side. Maybe they'll come in handy sometime in the future. Maybe. Let's choose the sequence of actions. So we'll start with the first pick. Again, we'll drop it in the center, and we'll move these 2 a bit to the side. Everything is as simple as possible here. We'll assign it to marker number 0. 0. We're interested in engraving the inner part, so that's again material removal at a density of, ideally, 1/100th of a millimeter, bidirectional and continuous. But here, since we have separate vectors for the inner parts, we'll use the bidirectional continuous setting. In other cases, I would use a slightly different hatch pattern, 100. But here again, there are a ton of nuances, of course, in reality. Alright, okay, done. Let's click. Actually, crosshatch will work too. Contouring is pointless here, because everything is fine as it is. Auto rotation is a must, otherwise there will be too many lines. So what else? To speed up the process, we won't use the cleaning mode here. We'll set the parameters like this. 3060, frequency 80, let's say 3060. That's a lot for titanium, but we're interested in speed. So we'll set the frequency around 200 kilohertz to reduce the Q-pulse. In advance. We're not interested in jumps here because we're using a slightly different hatch. Method, there. And what else are we going to do? We're going to cut the metal, so I'll set marker number 5. For the cutting values, speed 600, power. Yesterday we cut a great version, power 40, frequency 40. We're not changing anything here. In advance, for jump speed, I'd honestly set it to 1000. Or even better, for the jumps, I'd set it to 10, then 100, and 100. Wobble, or wobble, wobbler, 0, cut diameter, 0.3 millimeters, distance, 2/100ths. There, okay, done. So this thing will be engraved and then cut. Again, what else will we do here? Well, at least for this little piece, let me move it down a bit so you can see it too. We'll make a copy. Control C, Control V, step down, step left. And I'll change it to a marker. Let's say marker number 3. I'll change the hatch density here to 0.3000ths with a crosshatch. Let's go with crosshatch, for example. We won't need auto rotation here. Angle 0. 0. Click apply. We'll also link marker number 2. Parameters for this marker, 1600. Power will be enough. Power, 20 power will be enough. Frequency, 300. Yeah, this will be our mode for, let's say, setting the tempering color after material removal and another intermediate option before that. Now, let's group them all together so they're in one pile. There it is. And we move it up. There we go. Done. That'll be at the end. Control C, Control V, step down, step left, and we'll assign this one to polishing. Polishing will be with marker number, let's say 3. We'll polish at a speed of 2200, power 25. Okay, power 25. Frequency 280. Done. And what else are we doing here? It's the hatching for this marker, so marker number 3, density 0.005, more than enough. Bidirectional with an eruption, cross, hatch, no outline, no auto rotation, nothing else. Okay, done. The only thing is, I'll move it up just a little bit higher. And basically, these will be 3 separate files that we'll use for the work on our machine. Alright, now our task is to start the material removal, do 50 passes, but it says 100 down here. That was from yesterday. For cutting, let's set the value to 50. After 50 passes, we'll do the polishing, which is marker number 3, and after polishing, we'll do the tempering color with marker number 2, and finally, we'll set 100 passes in a gentle mode, specifically for cutting this material. So we have more than enough light. Today, unfortunately or fortunately, there'll be a camera. It's a Xiaomi 15 Ultra. A pretty good little phone. They fixed a lot of issues with this phone, which really makes me happy. In these spots, we physically won't have enough room to fit the pick, unfortunately. So we'll be cutting in new places. The metal sheet is essential. I'm clamping it down. The metal sheet we're using is titanium B6. Aluminized, springy metal. And we clamp everything as close as possible, because during the engraving process, overheating and deformation will occur, and the metal might warp. Well, that's about it. Now we set the focus and let's go. The process will take, well, within an hour, we can get one finished pick. Let's wrap up this intermediate stage of our work. Again, the removal and engraving of all items is going smoothly. Temper colors, well damn, anodizing is even more accurate here. So let's not forget that while one was being engraved, I was finishing the edges of another. Meaning I was slowly sanding it down, polishing it up in some spots. Here we have a through cut. You can see it really well, but I just haven't finished cleaning it yet. We still got an ultrasonic bath planned for it. And the cutting took about, let's say, along with the engraving and everything else, about an hour. If we're talking about these regular little ones, then engraving plus cutting is about 15 to 20 minutes, no more. The longest process here was actually the cutting, engraving plus the light polish, and let's say getting the tag. Damn, not tag. The pick to a certain state took about 3 to 4 minutes. This last version is the saddest one. I got a bit distracted by messages and other things I was doing. I lost track of the fact that it doesn't have any support for the center areas. And I noticed on the video that these frames here warped quite a bit. The inner ones, well, I think it surprised me a bit. You can't even bend them like that normally. Actually, why did all this happen? Because the piece itself started to shift. See? So here it cut through and then it started moving. It turned out to be a pretty cool thing too, I'd say. Through cut, now it needs to be sanded down and polished up. And maybe it'll also go up for sale eventually, so to speak. So here's this cutout tail. Anyway, we're done with the 2D ones, but I think this one is just awesome. Again, we're using Titanium VT6, the G50LP machine, gray controller, currently testing and trialing. And now we're left with the idea of making a 3D one. For the 3D one, we'll cut a pick like this now. Just cut it out, so to speak, so we have it ready. And then I'll come up with some kind of, 3D model for it to make it look more or less nice and decent. It's already 6 o'clock in the evening. There was a ton of work today. What I was doing just now with this controller test, that's all just playing around, really. These picks, made with the cutout again, well, it seems all cool and good. Chem. What's it called? Chemical anodizing was used here, actually? Well, it also looks pretty good. Cool. Unique. I just need to wipe off the fingerprints again. Yeah, it's also pretty cool, bright, saturated, all colorful. Titanium is the main thing here. With the cutout, it looks really cool. Lightweight, the first version. Moving on. The second version we had was just with regular engraving. I didn't bother standing this one. Thermal anodizing. The backside is a bit worse here. The front side was more interesting. Well, I shouldn't have been lazy. I should have used both hands to flip it and heat it from different sides. The edges and ends are all finished. Naturally, that's a separate process. I wouldn't want to say this so late in the evening, but I'm doing some tedious busy work. There. Next, engraving. Engraving of this format is still being lapped here, meaning we're rubbing it manually. That's a whole other story. This isn't just busy work anymore. Damn, we're actually, working with lubricant now. There. Also, thermal anodizing. I didn't sand this well. My mood just started to drop a little bit. The process where I basically cut it all the way through. Also thermal. But here I've already sanded and polished it. It looks pretty good. Let's even do this, ×2, so you can see. So polished, sanded, just awesome. There. And anodized using the thermal method. So it looks quite interesting. Moving on. What's under the tape is obviously set aside for now. It's dirty. The table is already dirty too. Our next stage was this 3D one. Also a pretty interesting topic, but there's a catch here. The catch is that we do the 3D on the Boss Laser, and for some reason in the Boss Laser, the engraving is done using the exact same coordinates and settings, but a millimeter lower. Wait, lower. No, not lower, but to the side. Basically, it shifts negative on the x-axis. I don't know, damn what that's about, specifically on the x. It's very strange to me, of course. But I compensated, did it, and engraved it on the Boss Laser. The 3D model itself. The cutting was done without CAD, prepared in advance. That was the first model. Our second model, damn, where is it? Here it is. It hasn't been processed yet. Nothing's been done to it. I just patented it. The 3D was also cut. I cut it right away while it was fresh, made the model itself a millimeter smaller, and immediately started the cutting. So again, under the Boss Laser, and accordingly, cutting directly under ASCAD 2.0. So you can combine them. The piece of metal itself looks like this. It has a light satin finish, titanium, 0.8 VT6. A cut of this format. All of this will, again, be sanded and finished manually. Anyway, this is how many we got today without pushing too hard. Again, there was other work in parallel, a bunch of messages. Damn, just a real headache today with everyone, with the clients. There, 6. 7 guitar picks? Again, I'll say it, without pushing too hard. The simplest option is engraving plus cutting. Without manual processing, it takes 15 to 20 minutes. So these are 2 options. This third option is also a very quick one. It's, well, 20 minutes at most, so you could cut these 3 in an hour. With deep cutting, like here and here, it takes about 45 minutes to an hour 20, depending on how hard we start pushing it. With the laser, I mean, here it wasn't hard. It took about an hour 10, hour 20. Here it was hard. Did it in about 40 minutes. 3D ones, accordingly, the 3D itself takes an hour and 20 here. Again, without pushing it. If you push the machine a bit, it can be faster, but the quality will be worse. Or you could say deeper passes, more passes, then they'll take 3 to 4 hours at least. Whether it's needed or not, who the hell knows? Cutting takes about 10 to 15 minutes in both cases. Well, at most. Depending, again, on how hard you push it. A similar 3D piece was made here on titanium back then on a JPT-50LP machine. Well, it looks okay too. Anyway, the finale. What's our video about today? We ran the controller for 9 hours today, and it worked quite well. No problems at all with it. I do these tests very rarely because 9 hours, I don't know how to put it anymore. To hell with it, I'm tired. Anyway, doing this kind of grind for yourself and the machine for 9 hours is, well, for some tests, it's overkill. But I did it today for the video, did a sort of final check today. There's a reason for that, because we have a great controller. They can, well, sometimes they might have some glitches. We test them sooner or later anyway, you know, before selling. But here I had to test a specific one to the max. That's it, guys. As always, a thumbs up from you and more interesting engraving content from me. Again, 3D engraving, everything I do mostly now on JPT50LP machines with the gray controller using the laser emboss software. All the links will be down there for RooTube, YouTube, VK, and damn, Telegram. In Telegram, we still haven't done the giveaway yet. The control, not the controller, but the dongle for laser emboss version 1.8.3. So go there and make sure to subscribe. To the Telegram channel, the giveaway will be held in the Telegram channel. Once we hit 1,000 people, we'll give it away there. Basically, as always, thumbs up again, and I wish everyone more good vibes and cash. The cost price, don't ask me about it here, because the cost is calculated based on the engraving time, the time spent on each item. I mean, how much you're gonna mess around with standing, 3D, 2D, through cutting. A local entrepreneur here just gave me a tip. He saw the videos, again, he watches the WhatsApp statuses. He says, it's cool with the through cut fingerprint, he says. But if it were a real fingerprint, I'll tell you right now, guys, a real fingerprint could turn into this kind of mess where it just cuts right through. I mean, a part of the element will fall out, which isn't good, so the same thing could happen with a fingerprint. Here, as you can see, we have a relief. Even though it's cut, it's still supported by pins somehow. And plus, don't forget, the fingerprint. That means you physically have to take it from the person, and accordingly, the next step, taking biometric data, leads to getting your ass kicked. Yeah, by our superiors. And the next point is very important. Whoever takes the biometric data, then God forbid, if something happens to that person's phone or some of their, I don't know, stuff, damn, you'll be the one to blame. So, well, I don't recommend doing that. Or get a signed paper that the person is of sound mind, meaning they'll never in their life have any claims against you in the future. Accordingly, they're giving you their fingerprint for engraving, for doing all that shit. But here again, there are a bunch of nuances. I'm telling you right now, it's not even worth getting involved in this. That's it, guys. I've given my opinion, shown the video, shown the topic. The machine, for those interested, the links will all be in the description. Message me on WhatsApp. Don't fucking call me 10 times a day and say that I don't pick up the phone, that I'm such a bad person. Because, well, damn, I'm filming videos for you. That's all. Peace and prosperity to everyone. Bye-bye, everyone.